Okay, kids, we're back today here, and we learned about refraction the other day, where light moves from one transparent material into another transparent material, like moving from air into glass, or air into plastic, air into water, or even the other direction for that matter. And the light changes speed as it moves from one material into another, and it also changes uh, direction. So one of the ways that science is turned into technology is having refraction be used with an optical device called a lens. Now, a lens has to be curved. Let me get a pen up here. It has to be curved. At least one side has to be curved, or it's not a lens. If the sides are straight like this, see all the sides are straight, or like that, those are not lenses. They could be clear and plastic or glass or whatever, but it's called a prism. As soon as there's a curved side, it can only just, if it's just one, that's okay. Like, look at this here. Look, only one side is curved. It's a lens, all right? So light is going to go through it, and it'll refract. We learned about refraction the other day. And since these are known shapes, we can use the knowledge of how light is going to bend in this predictable way to come up with devices like telescopes, microscopes, binoculars, contact lenses, and the eyeglasses that I wear. So by shaping both sides of the lens, it is possible to make light rays diverge. Remember, diverge means spread apart, or converge, come together as they pass through the lens. Relative to the object, an image is produced. Thank goodness an image is produced, or these glasses that I'm wearing would be useless. An image is produced by a thin lens, and it can be virtual, inverted, or upright, smaller, bigger, whatever you need, depending on what we have. So there's two categories of lenses. The first one is called converging lenses. Converging lenses. And if you take a look at it, each side bulges out. See how this bulges out? So these are also known as oopsie, let me get my eraser. It'll do that again. These are known as convex lenses, or they can be diverging. They spread apart. You see how it's bent inward. That's concave lens, also known as diverging. But as they say here, convex or converging lens, look, they're thickest in the middle. Concave or diverging lens, they're thinnest in the middle. The thinnest spot is in the middle. So here we have some pictures of lenses, right? Both a converging lens and a diverging lens. And they like to label different parts of it and give it names. So the one is the principal axis. So what is this principal axis? The principal axis. Well, it's an imaginary line drawn through the optical center and perpendicular to both sides. So here is the principal axis. Goes right through here. Look at that. Boom. Principal axis. You see it's labeled right there. Here's the principal axis here. Look at the principal axis right there. Principal axis. And you see it's labeled. Next, the axis of symmetry is an imaginary, so once again, it's an imaginary. You know, when you look at a lens, you don't see lines sticking out of it. It's an imaginary vertical line drawn through the optical center of a lens. So here is the optical center right there. There is the optical center. And you've got this line that cuts the lens in half. All right, that's the axis of symmetry because the shape is symmetrical on each side. Similarly here, here's the axis of symmetry. Goes through the optical center because the lens is symmetrical on both sides. Now, both kinds of lenses have two principal focuses. So let's talk about that. The focal point where the light either comes to a focus or appears to diverge from a focus is given the symbol F. So let's see that. The light rays came in. See all these red lines? They are representing light rays. They hit the lens and they bend to one spot. They converge. They come together to one spot. That is one of the principal focuses. And this is labeled F. Look at these light rays. They're coming in from the same side. Look, all these light rays. For example, here's one comes in, and look, they all spread apart. They diverge from each other. That's why this is a diverging lens. But if you were to extend these bent lines, if you were to extend these refracted lines back and use dotted lines, if you were to extend them back, they would all look like as if they all started here. They don't, but it looks as if they started there. So that's also labeled F. Now what about the other focal point? While that on the opposite side of the lens is represented by F prime. This little F and that little symbol here is prime. If you go on to study physics with me, which I recommend to you if you need to do that for your future, I promise to give you a lot of work, is F prime. Now it's the same distance on the other side. There's a symmetry to this. So there's the same distance on the other side. Let's go up to this diagram here. It's the same distance on the other side. What is that distance? Well, if you can see here, they're labeling it as little f. Same distance on the other side, little f, and little f. There we go. Now, what do we call this little f? It's called the focal length. Little f is the distance from the axis of symmetry, that imaginary line that cuts the lens in half, to the principal focus measured along the principal axis. So we're measuring this distance here to here. And it's the same on all lenses. Since light waves behave the same way traveling in either direction through a lens, both types of thin lenses have two equal focal points. What are they saying here? It's saying if you shine light from the left or you shine light from the right, the rules are the same. As long as you have a symmetrical lens, you're in business on either side. So here we are. Let's take a look at one particular category called a diverging lens, also called a concave lens. It's thinner in the center, and parallel light rays pass through the concave lens. So here's an object out in front of the lens. So light would leave this point on the object and spread apart. This light would leave the object and go through, okay? This means that the light rays diverge. Look at this light ray here and this light ray here, okay? They're spreading apart. They're spreading apart. And you get an image formed right there. And the image is smaller than the object. Now let me tell you something. I'm wearing diverging lenses right now. When I used to sit in front of the room and look at all your nice faces, I would see you, right? But if I were to take my glasses off, your image would actually be bigger. I would see bigger images of you. But they would be blurry and out of focus. Then I would put my glasses on, and my glasses are diverging lenses because I'm nearsighted. I can't see things far away clearly. All right. When I put my diverging lenses on, the image of you kids that I see is smaller. You actually look smaller than when I have my glasses off, but it's clear and sharp and focused. So that's why I wear them. And the next one is called a converging lens, also called a convex lens. Okay. And the light rays that pass through it that are parallel, they all come together. And it can cause an image to be upside down. So you know the projector we had at the front of the room, it would have one of these lenses in it, actually two of them. And it would flip one up. So one would flip it upside down and the other one would flip it the right side back again. And they are used a lot for projecting stuff. This, though, basically is a microscope. I remember when I was a boy, we used to get microscope lenses. Sorry, did I say microscope? magnifying glass lenses. So this is basically a magnifying glass. We would get magnifying glass lenses when we were kids, and we would get the little pinwheels that would fall to the ground from a maple tree and shine light through the magnifying glass, and then it would hit the little pinwheel from the little spinners that carry the seeds of the maple tree, and we would set them on fire and stuff like that. You got to remember, this was before Nintendo Switch. Okay, so what are you gonna do? So that's what we would do, and it would be a magnifying glass. Now, the interesting thing with this type of lens is if the object is very far away, the image is actually upside down. All right, the image is actually upside down. But if the object is really close to the lens, then the image is right side up and bigger. So look, here's the object. There's the image. It's been magnified. That's why we use magnifying glasses. If you have a magnifying glass at home, I suggest you try it. Look at something from a large distance from the magnifying glass. You'll see it's upside down. Then use it like you would use a magnifying glass and put it really close to something you want to magnify, and you see that the image is bigger than the object. And they showed you some of those things in the video, right? I hope you watched that video first, or as before this lesson. I know it's kind of a long video, but I'm showing them because I'm trying to show you real life examples, or this can get kind of, really technical, right? So I want you to see some real life examples from the video because we can't be together, sadly. So I know it's long, but please give it a shot and keep working. All right, keep working. Uh, Keep your good student habits going. This is a really critical time. You do not want to fall into bad habits. I'm telling you right now that that is more important than any of this optic stuff I'm teaching you and lenses and refraction and mirrors. Being a proper student, working hard, being focused, having a routine, being disciplined with your learning. This is the age where you are starting to form your habits. You're still in grade 10, right? You do not want to fall into forming bad habits. I'm not saying the times aren't tough. I totally agree with it. I understand that. All right? But we're all in this together, yes, but we're also have to make sure we're doing okay for ourselves and keep proper habits that we will keep forward into our lifetime. I used to be a student. I was in grade 10 once when I was at Stanford. Okay, that's where I went. Stanford, great school then, great school now. All right, and I still remember some of my friends wanted to goof around all the time, didn't form those proper habits. Well, they're still struggling now. Still struggling. I'm still friends with them. Or you can start to form proper habits now, and it will increase your chances of success in the future. But I can't do that for you. I can only suggest it. You got to do that for yourselves. Don't fall into bad habits.